Hyperscale for enterprises. You don't need to be Google or Facebook to achieve data center greatness. We all know about the economies of scale. Just imagine the economies of hyperscale. It's enough to make an average enterprise tremble. What chance of ever being able to compete in a market dominated by Amazon, Google, Microsoft, Alibaba, and other hyperscale giants? If that is your worst nightmare, then Brad Casemore, IDC's Research Vice President at Data Center Networks, has reassuring news. Yes, the hyperscalers have taken the initiative, but the vendor community is now seizing the opportunity to repackage similar technology for a vastly greater and ultimately more lucrative enterprise market. The very vendors who helped the giants develop their advanced solutions are now offering versions of the same technology at enterprise-friendly prices. Data center greatness. Simple on the outside, very smart within, can now be yours. That is nice to know. According to Brad, it's not just nice, it's absolutely critical, as we will hear in his opening presentation to this podcast before he introduces four other speakers: Mansour Karam, CEO and founder Apstra; Kyle Forster, founder Big Switch Networks, recently acquired by Arista Networks; Kevin Deierling, Senior Vice President of Marketing, Mellanox Technologies; and Mike Capuano, Chief Marketing Officer, Pluribus Networks. Over to you, Brad Casemore.
My name is Brad Casemore, and I'm Research VP for Data Center Networks at IDC, and I'm pleased to be able to host this panel today. We're going to talk about hyperscale for enterprises. Many enterprises today, as they look at their data center infrastructure, and particularly their network infrastructure, have a degree of hyperscale envy, and the panel participants today will address how they can satiate that and move on and actually conquer the problem. And as the title says, you don't need to be Google or Facebook to achieve data center greatness, certainly in a networking context. I'm just going to cue this up briefly, and I'm going to have our panel dive in. Just to cue it up, we've already established that enterprises are on a journey, and you've heard about it before, in digital transformation. That's really the driver. It's an imperative that all enterprises are pursuing. It's not an option these days. It's something that they need to do. It's something that they must do. It has significant applications for their infrastructure in their data center and their networks, because typically it must be modernized. They're dealing with very traditional, outdated architectures. They're dealing with operational models that have become outdated, and they need to modernize. They need to modernize architecturally, and they need to modernize the way they run their networks. So it's a design issue, it's a deployment issue, and it's an ongoing operational issue. As they look to what's happening, we see cloud as not only a destination for workloads, but cloud has its own operating principles. And when you look at the hyperscalers, they've been able to do things at unprecedented scale and with unprecedented agility. They've used comprehensive automation within their data centers for their data center networks. They have they were one of the earliest progenitors of course, SDN principles. They have used scale-out architectures in a way that has been tremendously efficient and effective within their data centers. They use real-time analytics increasingly and streaming telemetry in order to not only inform their policies, their declarative policies in their data center, but to run things more efficiently and to be able to remediate problems fast and more effectively. And this has allowed them to move from a reactive approach to a proactive approach within their networks. It's very significant. It's not just about remediating problems. It's about being able to plan for eventualities and to move to a very proactive approach. And they've done part of this through having the right abstractions and through using disaggregation so that they can innovate at speed on an overlay, on the underlay, in software and hardware. They can decouple those so that they can move very quickly. And enterprises aren't hyperscalers, right? When you look at their business, and we'll talk about some of those reasons why, but they want to move in this direction. I want to cue it up. I had initially 2 slides, but we've got 4 panel participants, and they all have something fascinating to say on this topic. I'm going to have them briefly introduce themselves, and then we'll dive right in. Kevin?
Yeah, so I'm Kevin Deierling. I'd probably talk a little bit more about switches than adapters in this session, because that's one of the areas where we really see the hyperscale guys have embraced disaggregation, where you decouple the hardware from the software. The other thing that I'd like to address is really the difference between an enterprise and a cloud, and how the enterprises are going to have to move towards the cloud model. We call it hyperscale for the masses. If I characterize a cloud guy, they have a protocol stack an enterprise guy, they have a protocol stack that looks like that's been given them by their vendors, whether it's a Cisco or Arista, and they do just a tiny little bit of actually monitoring and automation. And the cloud guys are the exact opposite. They have a really narrow protocol stack, and they do a ton of automation and monitoring. So I think that's something that's important for us to dig into.
My name is Mike Capuano, Chief Marketing Officer at Pluribus Networks. We are also focused on networking. As it turns out, whenever you're trying to automate a data center, there's been a lot of progress in virtualization and automation of the storage and compute layer. The network always seems to be the Achilles heel. Pluribus is focused on sort of bringing network automation, SDN control of the physical underlay, that's the actual switches that connect everything together. Network virtualization, which is creating an abstraction that's often referred to as an overlay, and network analytics. And what I'm going to try to talk about is an approach to delivering that network automation that works well in smaller data centers, whether that's a mid-market business who aspires to be like a hyperscaler or even aspires to be like a large enterprise, but it's too costly and too complex to actually get that network automation for that smaller site. And then also, we're seeing trends in general around distribution of data centers. So we're going from a model where there's a large, multi-football field size data center in Iowa to where there's a much higher distribution of data centers in your neighborhood. And how do you build automation for that type of environment that is cost-effective and scalable across that more distributed environment? So those are the things that I'll focus on.
Mansour?
My name is Mansour Karam. I'm the CEO and founder of Apstra. Apstra pioneered intent-based networking. We build software that sits on top of infrastructure, networking infrastructure, and provides powerful automation and abstraction across the entire life cycle of those network services, day 0, day 1, and day 2+, helping organizations consume infrastructure a lot more simply and to help them deliver on their business initiatives a lot more effectively. We've seen customers that have deployed Apstra software see a 99% improvement in their infrastructure agility, a 70% improvement in the mean time to resolution of issues, which is a measure of reliability, and an 83% reduction in operational efficiency, measured in terms of man hours required to deliver on a specific infrastructure task.
Cal?
Thanks, Brad. My name is Kyle Forster. I'm the founder of Big Switch Networks. And if you'll indulge me, I have a little story that I think is appropriate for set up the conversation. We started Big Switch in 2010, and 2 years ago, imagine that we're 7 years into trying to build the best SDN company that we can possibly build. And one of our customers, the chief architect at one of our customers, he said this quote, and he didn't even say it with us in the room. He said it, and it went viral around our partner who was there, and it came back to us. He said, I chose Big Switch because it was the closest I could get to Amazon networking on-prem. And it was a seminal moment for us, right? 7 years in, and suddenly it was like the light went off. This became almost a mission statement for the company. And suddenly we had so many things that we had to build. It really opened up at least our eyes, and certainly my eyes. Say, look, in so many different ways, the cloud is one. And now what can we do about it? Can we build systems on-prem that aren't inspired by public clouds, that aren't kind of like public clouds, but in fact that are exactly like public clouds. If you start with, hey, why don't we build the exact same experience on-prem that people get in clouds, if you use that as a starting point, then there are interesting deltas off of that. There are really, really interesting hybrid cloud components that start showing up. So this one quote 2 years ago sent us on this fascinating journey. And I hope to have the chance to be able to talk about that a little bit more.
Absolutely. One of the things, and you've touched on it, all of you have touched on it from different perspectives. That's exactly what we wanted, because I think you all bring a different perspective to this. There's no question that there is a demand for the sort of agility, for the sort of flexibility, for the sort of reliability, for the adaptability that hyperscalers have in their data center networks. But enterprises are enterprises, right? Many of them have bricks and mortar manifestations as well as digital. They are becoming more digital, there's no question about it. They have certain skill sets, they have certain comfort levels, they have certain cultures that are very different from the hyperscalers in their application mix. So how do you make this consumable and frankly simpler for them to be able to implement in their environments? I wonder, I think all of you can, there are different architectures. I know we have controllerless, we have controller-based, we have a mix of technologies and approaches here. I wonder if we could maybe get a perspective, Mansour, start with you in terms of simple is very important in this context, right? Because they don't have teams of PhDs in most enterprises, and they're looking to do this in a way that's consumable for them.
Yeah, I mean, what we've seen is that enterprise environments are, in some ways, a lot more complex than your public cloud. The public cloud has, a certain set of applications that's quite constrained. They're only building a product for themselves. When we're a vendor and we're going to the enterprise, every enterprise environment is quite different. There is various mixes of modern, cloud-native applications and legacy environments. And so the challenge is really to build a product that meets, that takes and distills, in a sense, the benefits that automation provided to public cloud providers, distill those benefits, but then deliver them in a package that applies or takes into account the complexities of enterprise environments. And so, it means different things. It means that you have to have the ability to support modern applications, but also legacy applications. You need to have an architecture that's quite extensible, because ultimately you are stitching within an environment that already exists where there are a different set of tools. And so having that ability to extend the product, having the ability to integrate the product within the environment becomes critical. And then you need to have an ability to apply to different domains. So you can't be rigid and say it's only going to apply to this exact specific topology, which is a lot of what simplifies the problem for these hyperscalers. Yeah. They only have one network, and that network is designed in a certain way. In enterprise environments, you have a variety of such networks, you have a variety of different domains, and you need to have a product that at the core has an architecture that allows you to adapt to these different domains.
Cal, how have you dealt with this with your customers from a big switches perspective?
Sure. I think there's this area that I'm really passionate about. I'm actually so passionate about it. I talk about this so often in the office and with our customers. A couple of my colleagues actually asked me to write up a LinkedIn post about it. The LinkedIn post flopped. I mean, nobody looked at the thing at all. But the really, really important part, I grabbed a snapshot of the Google search trends over the last 10 years for AWS VPCs, that's kind of the primary networking primitive on Amazon. Like, hey, you want to spin up a VM on Amazon? Well, the first thing that you do is you actually spin up a VPC, which is a network setup around it. And you see a trend line that just looks like this. And then I did a search for Cisco VLANs, and you see a trend line that looks like that. The two of them crossed 9 months ago. There were more Google searches for AWS VPCs than Cisco VLANs. It becomes this thing of how do we present an Amazon experience or an Azure experience or a Google Cloud experience on-prem? Well, it was kind of obvious for us the first thing we had to do was start by presenting VPCs. not kind of like a VPC, not sort of, but like the exact same object model. And I'm incredibly proud now that when somebody uses a Terraform, kind of a Terraform template on AWS, they can use the exact same Terraform template on-prem as far as networking stances go with our stuff. We're working on when somebody uses a CloudFormation template on AWS, you can use the exact same networking stances in that same CloudFormation template on-prem. This suddenly made a whole bunch of all of the cloud native integrations really, 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 really easy. Some of the trickier parts were things like Nutanix integration, vCenter integration. Those were surprisingly slick to make a great user experience. They actually translated into the VPC model much better, whether it's the VMware DVS or the Nutanix networks, the OpenStack Neutron networks. That translation was much, much easier than we thought. So it's kind of a way of saying, can you present, there's the networking team, but then what's the networking team doing to present an option for all of their colleagues? And if we're an extension of our customers' networking teams, this is our job. Like, how does our team present this experience? And our teams are no longer 80 people, 100 people, 200 people. There's an awful lot of the market that's now 4 to 7, maybe 10-person networking teams. And how do you get there? By presenting, when the team has the aspiration to present a cloud-like experience, how do we get them all the way there? And I think we kind of found the nubbin of that with VPCs.
Yeah, absolutely. Mike, I know, talking about customers and their evolution in enterprises, I know you have within your installed base some customers, we won't name them, but some customers have been around for over 100 years, and they've obviously gone through many IT cycles in that period. Could you talk about some of the challenges that they've faced and how you've helped them address going from very traditional environments, legacy environments, and moving on to a cloud era?
Sure. Your original question was, how do you make this more consumable? How do you make it simpler? I mean, I think the problem is this data center automation has been realized by, like you said, hyperscalers who have huge IT staffs, lots of PhDs writing code. Even in the larger enterprises who have achieved, say, a software-defined data center, they have really large IT teams. So our focus is, how do we literally do what you just said? How do we make software-defined networking, open networking, network virtualization, analytics consumable for the rest of the world? I'll point to something Kevin said in the last panel. How many panels are you on today, by the way? Your highest cost item in your data center is your CPU, your RAM, and your flash, right? So imagine you go from a large enterprise that has 50 racks down to a medium-sized data center with 4 racks, or a medium-sized data center that's moved into 4 different colos, and they've got 2 racks or 4 racks in each colo. How do you automate that? Because for the large data center, you've got all these external servers that you're deploying for management, for controllers for the SDN layer, controllers for the network virtualization layer, stacks of servers for network analytics. And in a big data center, that all just disappears. It doesn't matter. But in a small data center, all of a sudden, that's a big deal. So what we said is, hey, switch is being developed by companies like EdgeCore, Dell EMC, Mellanox, actually have pretty powerful processors in them, and RAM in them, and flash drives in them. And they're being deployed anyway, because you have to physically connect the leaf and spine architecture. So why let that latent server-like processing power go to waste? Let's leverage that, write some clever distributed code, so literally on the switch you have to deploy anyway. You're running your SDN function, you're running your network virtualization function, you're running your network analytics function, and then the other benefit is now I can pre-integrate all of that, pre-test all of that. It just works out of the box. And so that's why as a company we have some large enterprise, but generally we're not pursuing large enterprise. We are pursuing folks who have small and medium data centers, folks who are moving from a centralized model to a more distributed model, edge compute, where you've got these constrained environments, and that's the way we're trying to make it simple. To your earlier question, what did we have to go through with one of these larger customers? The good news is our design, like I said, kind of works out of the box, but for every deployment, and Kyle and I talked about this in the hallway, you got to have TAC. You've got to give those customers a lot of love and sometimes handhold them through it.
Absolutely. And Kevin, obviously from your perspective, you're a bit different, right? Because you've got network interface cards, you've got smart NICs, you've got network silicon, you got switches. So I wonder what you've seen from this perspective in your engagements.
Yeah, I think the key point here is that the cloud and the hyperscalers have these massive teams that have developed everything from scratch. And that journey that Kyle was talking about is exciting for us because we don't have those massive teams ourselves. And all the software folks that are here reflected at this table, we've been working with them for years. So Apstra is a great partner. How do you get automation if you're not Google or Amazon or Microsoft? Well, you talk to Apstra. That's how you get it. That's the thing. So for us, having an open platform that we can run different operating systems on, Sonic was something that Microsoft developed in-house for their data centers. They run it at scale. It manages hundreds of thousands of servers in their data centers. That's now available. It runs on an open platform like ours. And so companies like ourselves and Apstra and others are supporting a lot of that infrastructure that for the first time, smaller enterprises and mid-sized enterprises can take advantage of some of the open source code that's out there, things like Sonic, also other open platforms, big switches here, we've got Pluribus, we've got Cumulus who's not here. All of that stuff can run on these open platforms. So really you can steal a playing card from the hyperscalers today and deploy things. And for us, it's a double-edged sword. That means that you can, the folks that Pluribus was talking about here are our competitors, okay? When you disaggregate hardware and software, it means there is no vendor lock-in. It's not like Cisco where it's a black box and you get the hardware and the software together. If somebody offers better hardware, you can go buy it from them. And if you want to use whichever software you want, you can do it. It's finally all integrated and gives that choice. So that whole notion of open networking is really a powerful thing.
Yeah. So no, I completely agree with this, with the comments around disaggregation. And the way I talk about it is this decoupling that one has to do between the hardware and the software. And in fact, if there is one piece of advice that I give to enterprise organizations that are in the process of transforming their infrastructures is please don't start by choosing one strategic partner that is your established hardware vendor that you've been working with for the last 20 years. If you start there, then you're going to restrict your choices dramatically. You're going to lock yourself into hardware, and you're going to lock yourself into a fully integrated solution that is not best of breed, that will slow you down and will not deliver the needs of your business. And the reason why this is critical is because Gartner has demonstrated, has measured that digital transformations initiatives are 3 times more likely to fail if you fail in your process of infrastructure transformation. And so this is why we really ask organizations to look at software first. Look at that layer of software. What is that abstraction that you're going to start with as the foundation? Software is key. Software takes the critical role here. Once you've defined that, once you know what these abstractions are, once you've built that layer of automation, that service layer that will interact with your business applications, once you have that right, then choose your hardware. Hardware is critical, it's important, but it needs to be decoupled from that software decision.
It's a very interesting point. In fact, we found for traditional enterprises and their environments, they're still on, even in their data center networks, a 5 to 7 year cycle. But enterprises who are more software driven in terms of their approach to their networks and software led, there tend to be hardware benefits as well because they tend to be on a faster cycle.
Absolutely. In fact, there are so many vendors out there, and the right formula is going to involve a heterogeneous environment. There's going to be heterogeneous hardware, heterogeneous software. So don't lock yourself into just one integrated stack. Allow yourself the ability to leverage or take advantage of all those options that are out there. It's going to be a requirement for your business.
One thing that I mentioned, and definitely it's prevalent in hyperscale, now it's definitely moving to the enterprise data center as well, is the need for pervasive visibility of a real-time nature. Now, it's not just day two, right? I mean, there are many environments, I'm sure you've all found this with SDN, where they really don't have visibility into what's out there before they deploy, right? And how important is that insight into informing their policy? I wonder, Cal, if you could talk to that.
Sure. For a number of years, we built up a lot of actually analytics tooling and troubleshooting tooling by trial and error, which actually got us pretty far. One thing that started, I think, especially as we started doing this journey more and more towards replicating public cloud, we started looking at a lot of the SIGCOMM papers that were coming out from public clouds themselves on their own internal troubleshooting tools. So I separate out two things. How do actually non-networking professionals troubleshoot the network, the way that us as users of Amazon, Google, or Azure do? And there's some really interesting tools there. Something as simple as CloudWatch, VPC flow log. We should be generating those. But then there's also kind of through the SIGCOMM papers, through recruiting, you can kind of figure out some of the really, really successful internal tools that are being used to troubleshoot at these clouds. And then being closely inspired by those, it's very, very, very far, very fast. I mean, we see plenty of teams. The Azure team is a great example where they have a series of incidents that they published that in 2010 took them, about like on the average 20 hours for remediation. And now they're down to like 4 seconds because the average is 4 seconds because so many of them are machine remediated and a very small number involve any human at all. And they're published. I mean, this is all published work. So I think we've actually seen a huge boost here, both by going after all the public offerings that a networking team offers to other people to help them troubleshoot, as well as going after actually some of the in-house tools. And couple that with a lot of the trial and error that just comes from not only listening to users, but I mean, the much more interesting is actually watching users use a networking system and just jotting down where they start to look frustrated or jotting down where they're starting to spend a lot of time. Those user studies to me are fascinating. We don't do that very much in the networking industry, but gosh, do they ever tell you a lot.
Yeah. Mike, I wonder your perspective on this. I know the key feature in your portfolio.
Right. I mean, instrumentation, analytics is critical. I mean, going back to the statement around disaggregation, the value you get in a disaggregated world where you've got hardware innovation happening separately from software innovation, and they're not tied together, and one is not slowing the other down, is they can both move faster. So we're focused on software. We run on open networking hardware. We put a lot of energy into analytics, and ultimately, let me give you a use case. So we have, for example, a large school district deployed in the Midwest, 130,000 students. And employees, and they're distributed, right? So they've got multiple data centers. They use our fabric and its ability to capture every TCP flow to shut down DDoS attacks. And so what they can do is, because we present every flow that goes across the fabric, if they see some unusual spike and they look at this through our graphical user interface, they'll know it's a DDoS attack. And they will then use SDN. They can go to any one switch in their entire fabric, shut down a port, and it automatically, within a second, shuts down all the ports across the fabric and shuts that DDoS attack down. What that lets them do is not have a $400,000 a year DDoS cloud subscription. So it gives them that automation, it gives them that visibility, and it actually saves them a lot of money. Yep. So that's a financial result you could see from having good analytics.
Absolutely. Perspective on it?
Yeah, so we like to talk about mean time to innocence. When something happens in the data center and applications start to perform poorly, the first thing you do is go find your network admin and start screaming at him that it's got to be the network. And we call that the mean time to innocence. When can I show that there's nothing wrong with the network? It's something else. It's this application that's running on this server, which is spewing data, things like that. So we actually also focus a tremendous amount on the low-level infrastructure to provide analytics. So we have a tool that we introduced called What Just Happened, WJH. so that when things start happening, we keep a record of all of the activities that are happening, and we feed it to these guys so that they can show you, so that very quickly, instead of having to wait days and days and days, you can say, hey, it's not the network. The network is functioning just fine. It's that node over there is spewing massive amounts of data, or the database, it's pushing back for some reason that node there, this server or this SAP or Oracle, or those are our customers, so I shouldn't use them as examples. But it's really a critical thing.
It's a great point, and I think
analytics.
we all know the networking team often gets the blame for anything that goes wrong, and they love to be able to say, no, it's not us.
Exactly.
I think we have some time for some questions. Does anybody have any questions? Oh, we've got one up front here.
One of the key points that I see from the public cloud is a matter of abstraction. Mm-hmm. A lot of the low-level stuff, you don't need to touch. You don't need to think about it. It's automated for you. Yet you've all been talking a lot about producing analytics and delivering them to the end user. That's not something that's going to be wanted in that sort of environment. So what do you think about the arrival of new layers of abstraction through things like Anthos coming into the private clouds, into the build your own public clouds on your own hardware?
No, it is all about abstractions. You're exactly right. And it's interesting that while abstractions are critical to the public cloud, they're even more critical to your traditional organizations and enterprises who have a slew of different vendors and different, very heterogeneous environments. And so getting those abstractions right is not only critical, but it's also very, it's also necessary. It's also harder to achieve. How it relates to analytics is that abstractions is where everything starts, right? You don't see what's going on underneath, but abstractions describing what services you want from your infrastructure is the starting point. And then in order to achieve that reliably, not only does this starting point drive how you configure all of those elements underneath that you shouldn't be thinking about, but that the software should, but then also the software needs to measure the infrastructure, keep state of that infrastructure, and have the ability to verify that in fact the infrastructure is delivering on those services that you've laid out in your abstraction layer. So you need to have a very integrated approach where these abstractions, this service layer, is driving both the configurations and the telemetry that is being gathered and the tests that you're running in your infrastructure to verify that your infrastructure is delivering on what you need. It's a bit like a self-driving car. Your layer of abstraction is, I'd like to get to this destination. That's what you're thinking about. Then the software is both controlling all of the components in the car, but it can't do that if it doesn't know what's going on around. It gathers all this telemetry, measures this telemetry, analyzes it continuously to ensure that the car is indeed delivering on its intent, on your stated intent.
Exactly.
Well, exactly. That's the only way.
Exactly.
Without it, it's extremely dangerous. This is the first, if you look at the first generation of automation, it was defining abstractions and then just pushing configurations. And that's how there are so many horror stories you can find online about people losing their jobs and bringing down infrastructures in a way that affects thousands of devices, and you have no idea where to start in terms of debugging or troubleshooting this.
I think one thing that we found is we took an approach. Let's use Anthos, right? I think that's a great case study. So Anthos, before you roll up a pod, right, you roll out a VPC. Google-sensitive VPCs are actually quite unique and really easy to use. It's actually a beautiful model. But then if something is not working in there, or if there are a series of connections or performance issues that you didn't expect as the Anthos pod talks to some outside pod, then you have flow log. Right? And so users kind of troll through flow log to try to figure out what happened after the fact. I think one thing that we found is we started doing a lot of the base level infrastructure to expose VPCs and Flowlog on-prem. There are a whole bunch of tools, analytics tools that we started putting on top of Flowlog on-prem. I mean, think of it as like one-to-one NetFlow. Those tools were so useful and so valuable for in-cloud deployments that for us, we actually just launched this line of products that's actually in Amazon. I mean, for a number of years, we thought of ourselves as always building switch-side software, but actually all the software that we started building on top was so useful that we launched a bunch of troubleshooting tools for AWS. We're just about to launch troubleshooting tools for Azure and for GCP, and they're the exact same troubleshooting tools that we use to troubleshoot stuff on-prem. It's the exact same health check and monitoring check, and it's using actually the exact same APIs. So it's kind of maybe one of these kind of fascinating case studies. To your point of abstraction, when you get the abstractions just right, the tool chain you build on top, whether something is on-prem or in cloud, it's the exact same tool chain. And to the extent that as humans, we're like human middleware, all of us in this big tool chain, it kind of becomes the same team. And that to me is a really neat thing as we think about the careers of a lot of networking professionals out there who for a long time I think may have thought of themselves siloed on-prem. Can their careers grow to something where, hey, they're not siloed on-prem. As a network engineer, they take care of the networks, they take care of connectivity. Whether that connectivity is in cloud or on-prem, it just doesn't matter. It's the same team making sure that things are healthy.
Thank you very much, gentlemen, and thank you, audience, for hearing what these folks have to say. I think we can all agree after this session that there's definitely a need for data center modernization and certainly network transformation in the data center in order to support DX. Absolutely. Thank you very much.
Thank you.
Thank you.
Thank you, Brad Casemore, IDC, and thank you for his panel members, Mansour Karam, CEO and founder Apstra, Kyle Forster, founder Big Switch Networks, Kevin Deierling, Senior Vice President of Marketing, Mellanox Technologies, and Mike Capuano, Chief Marketing Officer, Pluribus Networks. And thank you for listening to this NetEvents podcast. A full transcript is available from www.netevents.org.